Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Illumin, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hi, everyone. Welcome again to the AI innovation space. I have Todd and I have Addison with me. So, Addison, how are you doing?
I'm doing well. How are you?
Good. Hi, Todd. How you doing?
Very good. Thanks, Yano.
Good. Okay, so we're going to jump right to it. Addison, I would just like you to take a few minutes to really talk about your educational background and some of your experiences in machine learning as you basically work through your education.
Definitely. I got both my bachelor's and master's in mechanical engineering, actually. I did a couple engineering internships and was realizing at that point in my undergrad that I liked what we were doing coursework wise, but not so much in industry. And so I started looking around for more alternatives in terms of future career path and was pretty interested in green energy and renewables. And that's what initially drew me to the Solar Durability Lab on campus. Wanted to do my thesis there. And once I actually got to working on the research, it was actually much more coding and data science than I had expected. The head professor there is very interested in that, and he had all of us take graduate courses in data science. I was really enjoying those, learning how to program in R, getting to do analysis and machine learning on solar related data. And so by the end of that, I decided I really liked the programming side of it more than the renewables. So kind of just a, I guess, fortunate scenario that it worked out that way. And then after I graduated, I wanted to take that opportunity to really pivot in the ML direction. And so I spent that first summer teaching myself Python and other deep learning libraries, trying to get my foot in the door at different places.
That's awesome.
Thanks for sharing, Addison. So you graduated with a bachelor's and a master's from mechanical engineering from Case Western Reserve University. When you were studying that, did they pretty much just teach you MATLAB and nothing else, and then you kind of learn R during your graduate work and then these other programming languages on your own, or was there any other programming experience that you were actually taught in school?
That's correct. So everybody had to take MATLAB as an intro class, and then the mechanical engineering curriculum had one more on top of that where we focused a bit more on algorithms. And I wound up TAing for the intro class for the last 2 years of school. So I guess I was around more CS folks in that sense, but that was really the only kind of formal training.
I see. Yeah, I had a similar experience when I did my own bachelor's and master's degree as well. So you mentioned your thesis that you worked on. Can you just explain that a bit more? Like, how did that lead to this interest in data science and wanting to learn how to program more?
So the main issue I was looking at is the polymer backsheet on the solar panel. So it's what seals the module from the backside. And there's different types of polymers that are used there. And we were looking at how those degrade under, UV exposure, humidity, heat, all these environmental factors that you deal with in the real world. And one of the failure modes that you can have is embrittlement of the polymer, and then it'll start to develop these little crack systems. And those are problematic because you lose the electrical insulation of the panel. And you can also have moisture ingress from humidity. And the difficult thing with the cracking was that previously it was kind of a qualitative, not present, mild, medium, severe kind of rating. There wasn't really a lot of way to quantify how far has it really gone. And, you want those kind of numerical numbers to do more precise modeling. So we had a surface profilometer that would measure the height optically, and it could do that very accurately. So I would get these profiles, and then you can see the cracks pretty distinctly there. So I would use machine learning to fit a model of, a regression of what we expect the true surface to be. And then based off of that, you could measure how deep are these cracks, how wide, how many are there, and then use those in downstream features as inputs to other models.
Got it.
Yeah, that was very interesting. So are these solar panels, are these like residential, commercial? I mean, what's the who is the end user on machine learning detection algorithm you're working on?
So it could be either residential or commercial. For us, it's just trying to steady the technology and improve the reliability, like what kind of materials could be selected that are more durable over the long run, so that then it incentivizes people to put in solar, whether that's residential or commercial, because they're getting a better payback period.
I see. So it's about basically altering potentially the way these solar panels are produced so that they last longer for everyone.
Exactly. So we're just studying what's out there, the kind of behaviors that we can see, and then trying to use that to guide sort of the long-term direction of the industry.
And for these types of activities, right? How do you generate the data sets used, right? I would assume that you're probably using some sensors, or I'm not sure. How are you collecting the data?
Right. So I collected most of this data set myself. I already had the weathered samples. So these had been outside for 1 to 5 years previously. And then I was taking those and running them under the optical profilometer. If I recall right, it would basically spit out the coordinates in a long kind of text file. So then I was ingesting those into data frame kind of structure within R, and then doing my predictions there.
Really cool. Are those readily available? What you use for the conversion, are they readily available on Amazon and things like that?
The actual measurement device?
Yeah, correct.
No, that's pretty specialized academic. It was definitely an expensive machine.
Yeah, I could imagine. What are some of the other, I guess, applications of this idea today? Do you see this also being very useful in developing like smart cities and things like that?
In terms of the renewables?
Yes, correct.
Mhm. There was actually a separate kind of branch to the lab, like a larger institute on campus, which was focused on renewables, not only solar, but all others. And one of the electrical engineering professors, his focus was on, that grid reliability and robustness. How do we design it so that it can communicate and sort of isolate different failure areas readily, or demand prediction and resource allocation. So I didn't get to be involved in that kind of research, but it did seem pretty interesting.
Right. What is the impact of a crack in a solar panel, right? What are some of the impacts a crack on your solar panel can have on your ability to have light?
So that polymer piece is basically the environmental seal for the module. So once that's broken, it's a safety hazard, but because of electricity and voltage, but also the cells themselves are expected to operate in this controlled environment. And when you start having more heat and moisture building up in there, then they can prematurely degrade. So
I see. So do you see it as having identified this helps to sort of extend the life of the solar panels, essentially, right?
Exactly.
I see. When these cracks are found, right, does that mean that the solar panel needs to be replaced? Or would that mean that basically that portion of the solar panel can be replaced? Does that make sense?
I believe it depends on what the manufacturing technique is. Yeah, how
I
that
see.
polymer backsheet is bound to the rest of the module.
I see.
They may have come up with ways to make them more separable.
That would be more effective, right? That would make the model more insightful, right? You could then install something that actually does that monitoring, and then someone can come and fix. It's just like having a smart roof, right? If you have a smart roof, if something got taken off of a specific, I don't know even if I'm not even sure if a smart roof exists, but if there was something like that, basically, if something came off on your roof, then you could literally sit on your phone saying like your roof on this portion of your house and on this specific layer has come off or has cracked or whatever, right? And then you
Mhm.
can go right to it and then just replace that specific part, and then that helps to extend the life of the solar panel. What do you think?
I think in the field that would be pretty useful. It's definitely harder to take these kind of detailed measurements. One way that we were trying to alleviate that is to correlate the mechanical cracking behavior to more of a optical indicator. So the other thing you can commonly observe with the backsheets is they are white to begin with, and then there's yellowing over time due to
Mm-hmm.
different chemical reactions. And
Mm-hmm.
there's a handheld measurements that you can go out and more readily obtain that in the field. And so we were looking from the chemistry side, can we identify what the mechanism of cracking is? And then are there sort of precursor reactions that will cause other observable indicators? The other one is that there's a gloss quantification you can do for the polymer. They tend to become more dull over time. So that's another more easily observed degradation mechanism.
I see. Got it. Thanks for explaining that. We can move.
Yeah, thanks for explaining that. It's really interesting. I know Yano and I are both passionate about green energy space and applications of machine learning there, but you decided to, sounds like, to pivot out of that particular area after you worked with Case Western and the Solar Durability and Lifetime Extension Center. So can you tell us more about, why you made that decision and where you ended up working next?
Sure. Yeah, going out of renewables, I guess, wasn't really a deliberate decision. It was more of I need to focus on the programming side of it, and
I
not
see.
having as much
Okay.
experience. I'll kind of take what comes by first.
Yeah.
Yeah, and that first opportunity wound up being with a startup of a friend of a friend that was with OptFit, and we were helping consult with this one group that was looking to build kind of a machine learning assisted writing program like Grammarly, but less so for your daily emails and essay papers, but actual professional writers who are doing novels and such.
Okay. Yeah, I've used Grammarly before. So how does this program work? Like, can you tell more about like what it's helping the writer do that you were working with on Upfit?
So the main proof of concept feature we were working on is the sentiment arc of a story. So, through a novel, how you have character and plot development to kind of lead the reader along to a climax and resolution in your typical narrative, and wanted to make that, I guess, more transparent to the writer as they're going along. So give them kind of a prototypical arc of sentiment throughout a story, and then analyze the text as they're writing and show them kind of how they compare at the same point to what is, normal. And then it's, I guess, sort of a creative insight to them of if I'm trying to follow this typical pattern, then I can definitely stick to it more readily. But maybe I also want to deviate from it on purpose at certain times. And I can see that I'm doing that. And so we would also delineate the prototypical story arc based on the genre. So they would kind of pick that as an input before starting the project.
So what machine learning tools were you using to assist with this? Any particular languages or applications?
We were using a lot of Spacey and NLTK to do different sentiment analysis models. So there's a nice data set called Project Gutenberg, which has the text of a ton of different novels going way back. I think pretty much as early as, books were started to be written, they just tried to digitize everything. So we had that to train on. We would use a more classic sentiment analysis data set like Amazon reviews or something of that nature to train that classifier. And then we would run it over these books as unsupervised data and look at what the typical change in sentiment was over the course of the book.
Got it. I'm very interested, Addison, in learning about how the internals of how some of these NLTK models, how they work. Typically you have basic classification problem. You have your data sets, and then you have these classes. You run your model on it, able to test, evaluate, and things like that.
Mm-hmm.
With regards to some of these sentence structure, sentence related problems, can you explain how that works? How is the model able to make a prediction?
Right. So back then was pre-Transformers and BERT and everything like that. So it's definitely changed a lot. But I guess the initial 101 way of doing it was some way of tokenizing your text input, whether that's character or word based, and then having a numerical indicator for each of those. You might choose to cut off certain ones that are not frequent enough, like it's a one-off word or it's a proper noun that only occurs once, and then you replace those with some sort of out-of-vocabulary token.
Yep.
And then, so we would go over a given sequence length of the text, so maybe sentence or paragraph, but then since they're all different lengths, you have to pad them to the same length so that you can pass this as a batch tensor to the model with the same dimensions on all axes. And with recurrent models like a LSTM, you would feed this in at each time step. The model basically gets to see that input and then record some internal representation of it that persists across the time steps. And it has the learnable weights to update that as it chooses. And then since it's a classification at the end, you have to, once the whole sequence has been processed, then based on the features that you have at that point, whittle that down to probabilities and a fully connected layer for the different sentiments that we're trying to output in that case.
Excellent. Yeah. So that would be if it was a sentiment analysis problem, right?
Mm-hmm.
I see. Got it.
So, Addison, I'm just curious. It was very interesting to hear about those details in this application. So, did you ever get this in front of actual writers and have them give some insights as to how they felt it was performing?
As far as I know, we weren't able to get quite that far. We'd finished building out the web interface around it. We were collaborating with another freelance web designer. And I believe the guys who brought the idea to us were still working on it for a while after that. I got my offer for another job kind of in the midst of this. So
sure,
I was not quite around to the end of the project. Financially, I'll say that was kind of short-term viable for me. It was very valuable on the experience side, but I had a bit of pressure to get moving on there.
I understand. Sure. That sounds like a good experience for you. So why don't you share with us where you moved from there? I believe you were working with Rekor recognition systems. Can you just talk more about that?
Right. So there we're doing completely real-time focused edge machine learning. So we're working with security cameras, highway cameras, traffic, parking lot, et cetera, and doing license plate and vehicle recognition. So say you have something set up over the main interstate through downtown, and we could watch 8 lanes of traffic on a 4K resolution stream and pick out all of the cars, all of the license plates. Per license plate, we would do the number as well as the state that it was from as a classification. And then on the vehicles, we'd be doing make, model, color, body type, year, and orientation. So classifying multiple attributes for each instance. Yeah, so I guess that was kind of the core product. It was sold as a subscription to customers. People would go a lot of different routes with it. You had tolling was a pretty obvious application. Parking garages would use it because they can check, kind of keep a state of who is in, how long have they been here when they check out. We can calculate their time, and car washes and drive-throughs. We're also interested in it from a customer loyalty perspective of seeing, who has shown up previously. And maybe if you have a profile with us, we can automate some things for you that, make your checkout experience quicker. I think that was also common for dealerships doing maintenance on just regular checkups for people.
I see. Okay. So I'm curious about the 8-lane and the tolling application. So are these cameras that Rekor owns, or are they getting the data set from the government or some other party that you guys were then using?
Right. Yeah, the cameras are not ours typically. So they'd be decent quality security cameras, not crazy expensive, probably in the 1,000 to 2,000 range maybe. And we provide them a license that unlocks the machine learning software. They install that as a desktop app on their hardware. And then it connects over RTSP to the camera to pull the feed real time back to the hardware. And then they're using their own local compute to do the inference. And then it gets kind of packaged up into a JSON, which is sent to a web server. And we hosted a cloud version of that. It's just kind of an aggregation of here's all the different reads that have been seen, from which camera, from what direction. Here's the crop of the vehicle, the crop of the plate, etc. So most people would just send that to our cloud hosted one, but you could also install the same web server on premise. So you could have everything, completely offline if you wanted to.
I see. So can you talk a little bit more about the cloud aspect of this? Were you guys using Amazon Web Services?
We did for the front end customer facing pieces. And then I'm also using it separately on internal usage for training the models.
Excellent. So let me ask you a few other questions. So with your work, how has AWS or Amazon Web Services, how have you been able to leverage it to get your machine learning work done, deep learning, whatnot? What are some of the services that you've been able to use on AWS, and how have you found it valuable?
Sure. I think the spot fleet option for EC2 pricing really comes in handy. Probably our biggest challenge deploying is that these models, we support them for a whole bunch of countries all around the world in different languages. So, we're training like one model that does US plates and one that does Thai plates and Japanese and UAE. So I think for a given release, we would wind up training something like 30 or 40 models that have to get packaged into this desktop app. And once all of the research is done and we're settled on the architecture that we want to use, it is pretty tedious to knock all of those out just one by one on your laptop or something. So that's where we use the spot fleets. So we had a job queue that we could populate and say these are all the configurations that I want to train. And then I'm going to spin up 15 GPU servers that are grabbing them and executing the jobs. So, the one hard thing is that you can get kicked off of the spot fleet. That's, I guess, the trade-off for having the lower pricing. But Amazon gives you a 2-minute warning signal. So you have that time to gracefully spin down the training, save a checkpoint, make sure that you can pick it up again from another instance. And the way that we were able to accomplish that is the data set and all of our training outputs we had on an EFS volume. So you can mount that to an EC2 on startup and it's instantly accessible just like a normal file system. But, we had terabytes of images on there. So that would get us quick access to the data and allow for persistence between different termination of instances. And then for the actual runtime environment, we packaged up the training code inside Docker, and then we'd use NVIDIA Docker runtime on the EC2 instance so that we can access the GPU from within the container. So we have complete control over the runtime environment, and then we get the same hardware that's available on the base host.
Got it. So, I'm very curious about how you guys deal with large data sets. And so which experience are you speaking of right now? I just want to make sure.
At Rekor?
Okay. Yeah, I just wanted to I don't want to dive into other stuff. But so at Rekor, basically, if you would explain, where are some of these like data sets sitting, and how do they get transported from where they're sitting into your S3 bucket?
Right. So the images are on EFS, which is
Okay.
it's similar to S3. It's a little more pricey because you can mount it as a file system rather than bucket access. And then the annotations we had in a Postgres database, I built the web server that we sent freelancers to, and they would do our bounding boxes and classifications and everything. We write those straight to the database. So we built that entire kind of labeling system in-house. Back then was not as many options out on the market. So what we set up is you'd make an HTTP request from the Spotfleet instance to the front end labeling server, and then that would stream a CSV with the tabular annotations like bounding box coordinates per image onto the instance, and then all of the raw images are just mounted off of EFS.
I see. Got it.
Yeah, I think as I've been monitoring the landscape of how those kind of patterns are evolving, it definitely seems like there's more tooling around S3, and PyTorch has their data package in, I believe, is beta release. Maybe it's past that at this point, but they're starting to focus more on streaming directly from
that's good.
S3, which I think is really nice because then you basically have the same setup for local development as you do for production. There's no distinction. You're just pulling from one source of truth in both cases. I think the question for me is, what's the network latency like on that? And can you keep the GPU utilized at 100%? But it sounds like it's more feasible than it used to be. I haven't really had a chance to put it to the test.
I will need to take a look at that as well.
Yeah, that's really interesting. Thanks for sharing that. So, it sounds like the main advantage of the EFS was just easier to work with PyTorch when you were using this, right?
Yeah, because you know how you can have a startup script for the EC2? We would have that configuration across the whole Spotfleet. So as soon as they come up, it's seconds you mount this file system and you have access to 5 million images immediately, like no download time, no anything. So
wow,
it's very nice from that perspective. I think it's just cost.
I see. So I noticed that on your LinkedIn it says you did some supervision of 10 annotators on this data set. Can you explain what that means? Were you like supervising people on this?
Right. So the labeling interface that I wrote, the front end, I also was managing all of our freelance contracts on Upwork for people who had access to that site. So I'd automated it so that as we got new data, it would assign it in batches to the given people. And there's sort of a several stage pipeline that things would go through. We have one crew that does all of bounding boxes for license plates and vehicles, and they would write any English numbers in place. But then for all of the foreign plates, you have to have a native speaker who can actually read those characters. So, based on the country that each plate was classified into by that first group, we'd have to split it out to the different language specialists from there.
I see. Okay.
And then towards the last year or so that I was there, I ended up hiring this one guy he's a college student, just crazy car enthusiast, wrote for auto magazines all the time, knew cars up and down. And we got him to come in and label our make model on the images. He just had so much more domain knowledge in that area than most of the freelancers that we could hire. And that was pretty cool working with him. We reduced the average error rate of that classifier, doing make, model, color, body type, etc. We reduced that by 22% without changing anything about the model, just having him annotate, I think it was 30,000 cars.
Very cool. Nice. So one thing I'm wondering about, I know you're not with Rekor anymore, but maybe if you can speak to, I'm assuming they're continuing in these areas that you mentioned. And you had also mentioned several potential customers for them. So like customers that tolls, parking garage, car wash, and then you also mentioned various countries. Do you have any like estimate as to like where the majority of their business is? Was it in tolling? Is it like in a certain country, or is it in parking garages? Any idea on that?
I think most of it's definitely US based, less that I recall. I think there's a pretty good footprint in Thailand and the EU. I don't really know too many of the details on that business side. I'd be more so guessing.
Okay.
Awesome. So we're going to move to, and this kind of ties to what you just mentioned, right? It appears like you also have some ML ops experience, right? Can you share a little bit about some of the things you've learned in the ML ops space? Just ML ops in general, not necessarily specific to a work or anything, but some of some of the things you've learned, do's, don'ts, things that you should really watch out for anyone who is listening who wants to be an ML ops engineer.
I think when I started to get into this was at Rekor with these releases where we're going to send out a whole new suite of 30 models, and we want to compare that to the previous one, make sure that we're not severely degrading the performance anywhere. Ideally, it's a pretty nice upgrade across the board of different models. And in general, what I think is very challenging about that, if you have a kind of append only data set where we're just adding more all the time and you're simultaneously working on new model architectures, different hyperparameters, and then also, we've increased the data set size by 50% since we last trained. When you get into debugging those issues, it gets pretty hard to really assign the blame for what happened if the performance does go down. So for me, I think the data set versioning is very valuable because in my mind, the optimal deployment pipeline is something like we've been improving the data set. We've been doing all this R&D. When we get to the point of we have a release candidate, I think you should train it, new architecture on the old data, see the real apples to apples comparison there. That's kind of check one. And then the second stage check is to roll the data set up to the most recent version. And then you have a pretty good quantification of how much did our modeling efforts improve the accuracy versus how much did the data set, collection or label fixes that we were doing have an impact. So I would say that's kind of the high level thinking that really got me into it. And then from there, if you want to implement a system like that, you need really good experiment tracking so that we can know this production model was trained on this version of the data set and this version of the code. And one thing that I find typically lacking in that regard is that a lot of people will consider just, the code and the data set. But I think the other large piece that you need to have a really good tracking system around is the configuration. You might have your training script with a whole bunch of arguments of batch size, learning rate, all these things that you are tweaking as you're doing your research. If you're just tracking the Git commit that you ran from, those will be kind of invisible to you. And so from the config side, there's this library called Hydra, which was put out by Facebook Research. And it's a very interesting way of looking at configuration. Like I would say there's kind of two patterns that are commonly used in machine learning where you either have argparse like any other Python script, or people will write YAML files. But there's downsides to both of those. Argparse doesn't really allow you much nesting in the structure. So when you have this expansive list of options, as you do in machine learning, it becomes pretty unwieldy. And then you can specify that better in a YAML file because you can make different sections. This is model, and then within model, we have optimizer and, learning rate, etc. But then you also wind up having a bunch of YAML files that you got to keep track of. And so from Hydra's perspective, you will kind of define your command line interface. The user who's running the script passes those arguments, and then that gets serialized to the YAML. So the YAML then becomes more of a artifact of the training process that you are going to upload to your experiment tracking server rather than the input to it.
That's pretty neat.
It's a pretty steep learning curve. I would
Yeah.
say it's really hard to find a good way to explain all of it, especially over audio. But I would definitely encourage people, pretty much everybody I talk to, I tell them to go look at that library. I think it's very clever.
Yeah. What's that library called?
It's called Hydra.
Hydra. Excellent.
Yeah, thanks so much for sharing, Addison. That was very interesting. So are there any other ML ops tools that you've used that you would recommend as well, or is that pretty much the one that you are suggesting to people?
That would be my go-to for configuration. On the dataset versioning, more recently, I've been using Dolt, and I really like that one. It's Dolt, D-O-L-T.
Dolt.
So it is a versionable MySQL database. So you can track diffs at the row and cell level, I believe. I think row level winds up being more relevant for most machine learning tasks. But, back when I was talking about streaming CSVs of annotations, that was difficult to track the versions. I mean, the options were kind of, I just keep a bunch of these CSVs around on disk and they're named by version, or maybe I commit them to a LFS repo for Git large file storage. But this is very much, Dolt is like a native Git experience within a database, which is, I think, exactly what a lot of people are looking for. It doesn't really address the versioning for images and large unstructured data. I would say usually at that point, I just wind up making the assumption that the images are static and, we have them in a storage location that people aren't going to be able to modify them. It's not great, but I think that's mainly the state of where things are at on the unstructured side. But for tabular data and for the annotations of unstructured data, Dolt is really great. So the CLI has the same add, commit, push, pull syntax as Git. So I think that's really easy for people to use and switch over to if they're already using Git. And they've built a pretty cool GitHub interface for it called Dolt Lab. I haven't had the time to play around with this, but I think it is very good from a collaboration standpoint. So you can have a web interface, like data catalog-ish way to browse your different databases, run queries, look at the schema. But then in addition to that, you can see the commit log and you can make issues, pull requests in different branches. So that's kind of where I imagine things going more in the long run of maybe, me as a machine learning engineer, I'm doing my model and I realize that, this subset of samples is labeled incorrectly, or like the annotators didn't understand the instructions properly. So if I'm, say, collaborating with a data engineering team that manages that, I can go on the Dolt Lab file and issue, and we can track the progress of this. We make a branch, do the fixes, and then you can also have release versions like you do on GitHub. So I like to think of that as kind of the handoff point between data engineering and ML. That's, I guess, what my optimal team interaction would be like, where data engineering manages all of the stuff that happens before Dolt, and then Dolt is the official thing that they're giving to us and saying, this is vetted and finalized and you can use it for training. We can always improve it, but here's kind of release 0.1. Go do your training, come back to us, we'll improve it.
Yeah, that's really interesting. I mean, I use Git and GitHub all the time for software code, but this Dolt application you're talking about really seems very promising if you're having data sets that you want to share and change. So thanks for sharing.
Yeah, I think a lot of the alternative winds up being take the JSON export from whatever labeling tool you're using, and then, everybody writes their own parser for that and stores it their own way on their own laptop, and that gets messy pretty quick.
So one thing we did want to touch on is current position with Baller TV. You're working as a machine learning engineer. Can you explain what Baller TV is? What are they interested in doing, and what your role kind of looks like there?
Yeah, the company does live streaming for youth sports. So we're doing high school and below club teams, traveling teams at large venues across the country. And then the business side is selling those streams as a subscription. So you've got primarily parents and family who are wanting to watch their kid. They want to be involved in the game, but maybe they can't travel for a weekend, or you want to share it with the grandparents. So kind of a way to build community around sports. And then there's, another side of it where you have very elite level high school athletes who are going to be the next Division I stars, the next pro players, and we're capturing their journey there to that point and highlight reels and footage for them to show to recruiters, or recruiters being on the platform, kind of scouting for talent. Yeah, that's a good overview of the product. And then on the machine learning side, our goal is to enable scale of this so that we can stream more games, more venues. The way we're doing that is automating the camera movement. So in real time, we have got an iPhone set up on a tripod with a fisheye lens. It can see the whole court field of play. And then based on different computer vision models, you can imagine like object detection for players, balls. And when we have this scene understanding of what is going on in the game, we can then take a subcrop of that wide fisheye view and move that digitally. So the camera itself is perfectly stationary. Someone can basically set up the tripod and walk away, and it will run the whole game on its own. Yeah, so that's where the machine learning side comes in.
Awesome. So we're going to move right along. What are some of the challenges you face with machine learning products and models just in general? And it was just fun talking to you. Your experience in this space is awesome. I'd like to know, what are some of the challenges that you currently face in space, machine learning products, models, and then we can dive into, I have about 2 other questions I wanted to ask you after that, but yeah.
Sure. As I alluded to with the data versioning, I don't think there are a lot of great tools out there at the moment for images. It's just tricky to version and share data that takes up so much storage space. So I've started to see more development in that area of tensor specific storage, like how do we optimize storage for structured numerical arrays, because that's basically what you can boil images down to. So I think it's getting more attention, but it's definitely far from a solved problem. And that makes it a little difficult, as the last 2 companies been 100% focused on computer vision applications. So images as input data are what we have to deal with there. I think this streaming from S3, like in your PyTorch data loader, that seems really promising to me, because even if you get the versioning aspect down, it's kind of a pain to maintain your own copy of a million images on your laptop just so that you can run some R&D experiments.
Exactly.
That gets pretty annoying. I think I got my laptop for the current position spec'd with 4 terabytes of storage, and that's getting eaten up faster than you would like.
Oh, yeah, I know, and I know all about what you're talking about right now.
I know.
Yeah.
Yep.
So, there's a really cool project called Hangar, Hangar. It has gone stale since, and the lead developer, he's over at the PyTorch Lightning team now. I've talked to him on different Slack communities, but I felt like he was really onto something there in terms of the unstructured data versioning. So I would recommend people go check that out to get kind of an idea of what could be possible in the space. There's a really interesting issue thread on there where he's talking about performance of push-pulling images, and like, how do you optimize it so that the data transfer is minimal when you know the diff history and which parts have changed. It's very different than working with text data, which is what Git has been optimized for since it was created. And so I think that's kind of the fundamental problem, is we have a really solid concept of version control for small text files, but how are we going to adapt that to different types of source data? The other big pain point for me is working with edge inference devices. So at Rekor, we're dealing with basically whatever hardware the customer wanted to provide to us. And we would optimize our models to run on really slim CPUs and even some of the NVIDIA Jetson boards. And similarly at Baller TV, all of our models for the live streaming are running on an iPhone. And what I find in all of those scenarios is Each chip manufacturer has their own specialized acceleration framework. So you've got TensorRT for NVIDIA devices and CoreML on the iPhone. And, you can't train in those formats. You're going to do it in PyTorch or TensorFlow, and then you got to deal with the conversion, and certain layers are maybe not supported at all, or if they do run, they're not enabled for the acceleration chip. So then you're going to have memory transfer back and forth from CoreML to the CPU device, and that introduces a lot of latency into your inference speed. So I've always found that pretty challenging to handle the conversion process. And then also usually whatever inference code is calling the model on the device is going to be a different language. Like on the iPhone, you have to write everything in Swift and Objective-C. And those are not languages that you do your deep learning development in. So a lot of times it can be, I'd say, tricky to figure out the parity between the different environments. Like, hey, I'm running this model and I'm getting great results locally, but when we try to put it on the device, it's just garbage. So we've somehow missed a conversion between like channel order or array storage formats. And those definitely take a while, I think, to get to a mature phase where you understand what that process looks like. And you can be more certain when you send something to the device that you're actually going to get the results that you want.
Mm-hmm. So, yeah, thanks so much for sharing the challenges you're facing. Hopefully people are working on these kind of problems and starting to think about these, and in the future, we won't have these kind of problems as much in machine learning.
Mm-hmm.
So, one thing we're wondering, you've kind of mentioned before, some programming languages and frameworks that you use for machine learning. Any ones that you really like the most or you really look forward to using?
PyTorch Lightning is my favorite. I got into PyTorch at the time of TensorFlow 1.0. So that was a pretty easy choice. I think a lot of people kind of have nightmares about working with 1.0. I know 2.0 TensorFlow is better, but I've been in PyTorch in that ecosystem for so long that that's definitely where I prefer to work when possible. And I think Lightning is a really brilliant extension on top of that. Normal PyTorch is so flexible and everybody kind of writes their research in their own way, like how they organize their training loop and their model checkpoints and so on and so forth. And Lightning is kind of a way to abstract all of that into different class methods that interact with each other. So yeah, I think a lot of people compare it to like Keras for PyTorch. So you've got the model class, which defines the layers, but then it also defines what a single training step looks like and an optimizer update and what the learning rate schedulers are. And then there's a data module that encompasses, training, validation, and test all under one object. And then a trainer, which can work with both of those to actually execute all of your epochs. And the trainer abstracts a lot of the engineering code. So you can run this on CPU, GPU, multiple GPUs, distributed GPUs. There's all sorts of different accelerators that they've built into it. So that makes it really easy to scale kind of the engineering infrastructure needed to run bigger, faster trainings. So as a practitioner, that lets you focus a lot more on the actual research code, like what's the model implementation and the optimization routine. And then I would say the other big plus is when you standardize things in this kind of interface, it makes the collaboration really easy on a team. Like I can go and look at somebody else's model and very quickly understand kind of the crux of the different machine learning pieces that they have in place and how they're going to interact together. So that's definitely valuable on an internal team, but even more so externally. I wish so much that researchers would write their code in Lightning, because every time, you read a paper and you get super excited and then you go to their implementation and it takes you hours or days to get this working and adapted to your scenario. So I guess that's really my hope for the long term, that there's more community consensus around what is a good kind of style guide for how we write deep learning code in a way that makes it easier for other people to understand it. Because I would say the algorithms and everything are already complex enough. We don't need to add code structure on top of that as something that is confusing.
For sure. That definitely seems like a valid point. Thanks for sharing about some of your favorite programming languages in machine learning. So, well, you've mentioned with Rekor and with Bowler TV that you're basically working with computer vision problems and you have imaging data that you're converting into arrays. Are there any other particular applications that you haven't really worked on that you kind of feel would be something that you would be interested in doing maybe in the future, or that would lend itself kind of easily to the techniques that you've already kind of developed for these other applications? Any other like real world applications you're interested in?
I've seen some interesting projects that do machine learning assisted autocomplete for IDEs to give you better code suggestions or tips as you're developing. So from the NLP side, I think that would be a pretty cool application to work on. I've never had the opportunity to do anything in speech and audio, so that could be neat to see something different. I guess in the end, I don't have too much preference, as once you take it from the source data and encode it to tensors, you're kind of dealing with pretty similar process from that point on. And, that part of the development is what I enjoy. I would probably pick computer vision over NLP, just because it's maybe a bit, you can kind of imagine so many things that you walk around and you're looking at every day, and you start to think in your head of building like object detection and classification pipelines to do these kind of common tasks. So maybe that's just the way I think about it, because I've been working in that area for so long, but I do find it really interesting.
Got it. That's excellent. That's awesome. So as we wrap up here, I just wanted to also I was going to touch on two things, but I'm going to put them all into one. What pipelines do you use for your AI ML work? I know that there are like things like Airflow and stuff that are there. Is that something you're familiar with, or?
I haven't gotten into those kind of graph and job orchestrator category of tools. I think I would like to for automating these kind of cloud trainings, your finalized production one. Back when we were doing that at Rekor, we wrote most of the queuing logic ourselves, which I think there are definitely better ready-made solutions for that. So haven't had time to get around to that at Bowler TV yet, but would definitely like to explore it more when we get to that level of maturity. I think for me, the most important step is just getting good tracking and reproducibility first. And that kind of comes from how you organize your training script and your model and data library. And if that runs well on a local computer and I can log it to an MLflow server, I feel pretty good about that stage, because I know that from there, it's the incremental effort to go to, a Docker container that is then distributed out to different machines by an orchestration tool. That to me feels like the easier part than writing your code.
I get it. Yep.
Mm-hmm. I think aside from Airflow, the other one that I kind of consider in that category is the Ray ecosystem, that does Ray tune. They also have kind of job queuing and resource management libraries. Haven't had the chance to dig into them, but I do like RayTune for hyperparameter work, so
I see.
It might be kind of convenient to put those together.
Got it. Excellent. Wow, this was awesome. This was it was really, really fun having you around, Todd.
Yeah, we really enjoyed having you on and you sharing about your experience and knowledge in the space. Appreciate it.
This is good. Thank you so much for joining. And I'll just wrap up here. Thank you all so much for joining us on another edition of AI Innovation Space. It was great to have our guests, and we're looking forward to having you guys back on our next session.
Yeah, thank you all for the invite. I really appreciate coming on and talking.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.